And now, our final and highest honor, the Energy Innovators Award, and its grand prize of $10,000. To present this award, let me bring back Vikas Dole, Senior Vice President. Over to you, Vikas.
Don, I'm really pleased to announce the grand prize winner who will take home the Energy Innovators Award of $10,000 prize. This team really provided a holistic approach, community focused, practical yet innovative. They focused on a area of Lake Town in Kolkata in India, which is a densely populated area and region. They interviewed key personas to really understand the community challenges in terms of reliability of power supply, sanitation needs, and so on. This region is highly dependent on coal, which creates its own challenges. So the team came up with alternative energy sources of solar, as well as the strategy of coal-based methane, and then bioethanol for cooking. They developed a detailed community plan, including selection of materials, also apartment costs that suited the financial situation of the communities they're serving. It included rainwater harvesting and a detailed phased approach and cost analysis that also included government subsidies. So it was a good combination of community challenges, addressing the community challenges, innovativeness, practicality, and economics. The judges felt that this award entry really had a good combination of depth of analysis, technical excellence, and real world impact. Extremely well rounded across energy, water, housing, and detailed financials and resilient design. So, this year's Energy Innovators Award, the grand prize of $10,000, goes to Energy Xcelerate from India. Congratulations to the team. A remarkable achievement.
Namaste. We are Team Energy Accelerate. India is a developing country with dense population and heavily relies on non-renewable resources. And hence, for the development, we must find a solution that balances both sustainability and affordability. My name is Sanika and let's delve right into it. We have chosen a 67 acres area in Lake Town, Kolkata as our site location, and we have chosen this area in such a way that it is closer to the essential amenities like schools, hospitals, police stations, etc., which are suitable for our target audience, which is the school teachers, nurses, students mainly. To understand this location better, one of our teammates has visited the site location and interviewed a couple of people. Some of the most pressing issues that we understood were entangled and messy transmission lines, tilted poles, which are very unsafe in nature. Secondly, regular power cut issues were mentioned by a lot of people. Unclean cooking fuel, improper garbage disposal, and very bad air quality were a few more issues that were mentioned. Now, we have analyzed these issues and have segregated these issues into two parts, general and site specific, as you can see over here. Moving to the first problem, that is reliability during the peak hours. The grid lines of Kolkata are slightly old and unorganized, and hence, during the peak summer times, the people often face huge power cut issues due to the high demand that the grid cannot supply. Second issue that we see that Kolkata is very prone to natural calamities like cyclone, and in the above slide we can see that they are quite frequent. Occurrence of such calamities leads to messed up transmission lines and frequent power cutoffs. Another very pressing issue is the dependence of Kolkata almost entirely on coal based electricity, which is not only renewable in nature but also leads to huge carbon dioxide, NOx, COx, and particulate matter emissions, and hence needs better sources of energy supply. So, to solve the issues, we first try to understand the energy demands of a community housing 2,000 households in a metro city like Kolkata. Here, we have tried to break down the energy requirements of a single household, assuming that it will consist of AC, refrigerator, fans, TVs, and so on. The ratings as well as their quantities have been mentioned above. Here is our solution proposal. We have tried to understand the availability and affordability of different sources of energy, and we have found out that the combination of solar, CBM, and biomass would be the best suitable for us. We have divided the solar, CBM, and biomass into a ratio of 67, 30, and 3.
Let's move on to the solutions. The community we have built have three parts: one solar, second CBM, and three biogas. To sustainably power a 2,000 family community, we have adopted a hybrid solar solution, rooftop and floating solar. We're using high efficiency monocrystalline panels with rooftops covering 50,500 square meters and floating panels installed over 6 acres of water bodies. Floating solar boosts efficiency by 15% and conserves water by reducing evaporation. It also helps in pisciculture by reducing the temperature of the water and also allows the fish to survive. Our site's solar potential is 6872 megawatt hour annually, giving us a total installed capacity of 5 megawatt, meaning 67% of our 7,000 megawatt hour demand. A 5 megawatt battery system ensures reliability and surplus energy will be sold back to the grid, making the system both sustainable and economically smart.
West Bengal's deep coal bed hold large methane reserves, a clean, reliable, and affordable energy. On regular days, CBM covers 30% of daily energy needs. During cloudy days or cyclones, CBM team ups with BESS to power the whole community. With a total capacity of 3,200 kilowatt, our CBM plant keeps the light on even in emergencies, turning waste into power. We convert 1,200 meter cube of sewage every day into biogas, generating 2 to 1 megawatt hour of clean electricity each year. This meets 3.2% of communities' yearly energy needs, reduces pollution, and even produces free fertilizers. We have three major upgrades to ensure steady energy needs. One is underground cabling that cuts outages and boosts safety. Second one is central distribution hub that balances power from all the sources. Third one is smart meters that monitor real time uses, reduces losses, and help household manage their energy. Let's connect the dots with an energy flow diagram. Rooftops and aqua solar panels generate 6,872 megawatt hour each year. CBM adds 2,100 megawatt hour and biogas gives 221 megawatt hour. All these energy flows to the our central hub. Here, smart meters send extra power to grid to sell and automatically switch to CBM or batteries when solar drops. Let's talk about bioethanol, clean and affordable cooking fuel. Cocoa cookers run on bioethanol made from sugarcane, making cooking fuel 50% cheaper than LPG. Only 0.62% of West Bengal's sugarcane harvest is needed to meet the demand. It is supported by government policies. This solution is safe, green, and perfect for our community. With CBM, biogas, smart grid, and bioethanol, our community can have reliable, sustainable energy. Thank you.
We would now begin with the building design and community plan section of our presentation. As you can see, the local water bodies, flora and fauna has been conserved to the maximum extent. We have achieved this by designing our housing units around the existing site features, roads, so as to minimize the cost of construction and conserve as much resources as possible. The site plan overlapped with the satellite imagery shows how efficiently designed our society is. The building elevation renders and design features. As we can see, the use of brickwork has been maximized for the building design so as to reduce the use of concrete and steel as designing structures. The large windows and fenestration details have been done keeping in mind the warm and humid climate of Calcutta. The use of brickwork allows us to reuse the maximum amount of materials from the existing site. As we can see, the design elements uses an extensive amount of brickwork so as to minimize the use of carbon-emitting materials such as steel. An extended balconies with plantation has been done to enhance the wind flow and overall well-being of the residents. Solar panels have been installed in the rooftops to be used as terrace shades and also to enhance the energy independence of the site. The floor plans. We will provide three different housing types: 1 BHK flats, which are LIG housing, 2 BHK flats, which are for the MIG housing category, and 3 BHK flats, which are for the HIG housing category. As you can see, the housing units have been designed keeping in mind the air circulation and views. For every unit, you have three side open views, wind flow areas, and spacious balconies so as to enhance the well-being of all the residents. In this unit, you have 4 flats per floor, 24 flats per building. The 2 BHK floor plans. As we can see, you have followed the similar design theory, enhancing the quality of life and providing 3 side views to all the apartment units. The 3 BHK floor plans. As you can see, balconies and terraces have been provided on both sides of the housing unit so as to enhance the living conditions of the housing units and the residents living there. As mentioned, the use of wind tunnels and ventilation chambers have been maximized so as to provide natural cooling and reduce the air conditioning costs. The additional greenery in balconies and terrace areas reduces the indoor ambient temperature. The amenities we have provided in the proposed community. The community is packed with facilities such as rainwater harvesting, on-site sewage treatment plant, grey water treatment, biogas plant, on-site pisciculture, and methane-based power generator. This ensures energy independence and also reduces the energy cost for all its residents. Located very close to the train, metro, and bus stations, this provides additional infra for the community as well. Facilities such as jogging tracks, children play area, shopping complex, and natural swimming pools have been developed for the comfort and convenience of the residents. Engineering and material design solutions. We have extensively used Persian wind catchers to reduce the ambient indoor temperature. These wind catchers are known to use stack effect and Venturi effect to keep the indoors at a very comfortable temperature zone. Next up, we have polystyrene extreme foam boards. These are quite structurally stable and are known to provide both sound and thermal insulation. These are quite capable of providing natural blockage to heat and keeping the indoors comfortable, hence reducing the need of air conditioning. Double glazed glass windows. These glass windows use the vacuum in between them to block the UV rays, hence blocking the heat gain during the summers and heat loss during the winters. These are quite effectively used to reduce the heat in quite hot and tropical climatic areas. Next up, we come to the innovative materials that we would use to construct and design the houses. First up, we have the mud block masonry walls. These are blocks made using compressed earth and they are quite aesthetic while being strengthy and durable. They have one of the lowest embodied carbon energy and carbon footprint of all building materials. Combining mud block walls with adobe blocks or rammed earth walls provides one of the most thermal resistant buildings that are also structurally stable, aesthetically appealing, and have the lowest carbon footprints. We have highlighted the benefits and how they are different from other building materials. Instead of using paints, we would be using mudline plaster rather than chemical paints. These have low or zero VOCs for healthier air. They can improve air quality and they are quite aesthetic compared to normal chemical paints. For floorings, we would be using locally sourced oxide flooring or Athangudi floorings. These have low transportation costs. They help the local laborers and also they are quite environmentally friendly compared to other chemicals or ceramic based tiles. Coming to the roofing materials. The roofing would be a combination of brick slabs, stone putty slabs or clay pot filler slabs. These slabs are quite effective in thermally insulating a house and protecting it from the extreme heat. Clay pot filler slabs are an innovative way to increase the airflow within the household and reduce the heat gain. Summarizing the engineering and material solutions, we have highlighted all the materials and their top benefits on this slide. Water conservation and sewage treatment pipelines. Rainwater harvesting. About 400,000 cubic meters of water falls across the 67 acres of the site. Extensive use of rainwater harvesting has been done so that we can conserve at least 30% of the incident rainwater and use it for landscaping or non-essential water supply purposes. Next up, we have grey water management plan and its reuse. The grey water generated from the kitchens or the bathroom can be stored, filtered, and cleansed to be used again to be flushed through the WC. About 30 to 40% of the daily water usage is attributed to flushing the toilets. This massive amount of water usage can be supplemented by the innovative usage of treated grey water for flushing and cleaning purposes. A detailed flowchart has been given on this slide.
Moving on to the phase plan, our project will follow a 4 structured year plan The first 9 months cover site assessment permits and tenant reallocation. Phase 3 includes 2.5 years of core construction, followed by civic infrastructure in Phase 4. Phase 5 focuses on post-handover maintenance. And now look at the costs. Construction costs are 2,400 rupees per square meter with a 5% contingency. Key materials like cement, bricks, and paint have been carefully chosen to ensure quality within budget. Now let us evaluate the benchmarks. First of all, affordability. Our housing model is built in dual income earning home with 60,000 rupees a month. Compared to nearby communities, our EMI is lower and monthly savings are higher by over 11,000 rupees, making our plan significantly more financially stable. Second, our energy and carbon efficiency. Our community ensures zero power outages thanks to reliable solar and CBM backed systems. In contrast, neighboring areas face up to 360 hours of annual outages. Our carbon intensity is also markedly better, just 0.0023 kg CO2 per rupee, making this a model for eco-conscious living. Third, emissions and indoor air quality. While scope 1 emissions increase slightly due to biogenic ethanol usage, we completely eliminate CO2 from diesel generators. Scope 2 emissions drop by 80% thanks to solar adoption. We also outperform the surrounding areas in air pollutants like PM, COx, and NOx, delivering healthier homes. Mitigating risks. We are prepared for every scenario. On peak days, our 3.2 megawatt CBM 5 megawatt solar plants meet the loads. In winter, solar alone can meet 98% of the energy needs. During hurricanes, our underground lines and BES systems ensure uninterrupted supply. So our consumers buying houses will definitely love it with affordable, better air quality with least outages. Now, financial analysis. The project costs stands at $75 million, with $14 million coming from the government grants and $61 million coming from multilateral loans at 6% interest. This will be repaid within 18 years, after which the project will generate $7 million dollars in annual profits, making it not only viable to the buyers but also highly profitable for developers. I am Miraj, and with me were Sanika, Sachin, Udipan, and Avantika. Thank you for so much for hearing us out.